Hello, everybody. Nice to have you all back here. I want to say, so this is Friday afternoon. Our Friday morning class went well. I'm sorry about the internet issues of getting back to the main room. That's going to happen sometimes. In the future, if you're experiencing that type of internet issue, try to put your video thing away. Just go on audio. Don't have the video camera on, okay? I want to start this by kind of debriefing what we talked about at the beginning. So our original screamer Ferris wheel, all the way back to the original. Our radius is 100 feet and the center is right on the ground. And if we want to graph the height function, which is what we've been doing for a while now, we know that for every 360 degrees took 360 seconds because it was 1 degree per 1 second. So one cycle is 360 seconds, okay? Now, let's do a quick graph of this right here. So I'm gonna draw my y-axis, I'm gonna draw my x-axis right here. I know that 360 is my cycle, so I'm gonna mark 360 somewhere down here. I know that halfway in between the beginning and 360 is 180. I know that half of that, or 1/4 of the whole thing, is going to be 90 degrees. And halfway in between 180 and 360 is 270 seconds. That's right. I said degrees, but this x-axis is in time, in seconds. Okay, and then our y-axis is normally in height, and we'll put that in feet. And we have 100 feet being our tallest position and negative 100 feet being our lowest position right here. So we know that at the loading area is 0 degrees, and we start here at 0 feet. At 90 degrees, at 90 seconds, it'll be at the tallest position, 100 feet. 180 will be back down at the lowest position. 270 will go all the way down to the minimum, and then 360 will be back up here at the loading area. So I'm gonna draw this quick graph right here with my nice curves here. Japan, all the way down here and up to here. Okay, and then it keeps going on and on and on as the Ferris wheel does. Now, today, or on Friday, today, our question was, our engineers want to build a twice as fast screamer. So instead of taking 360 seconds, they want it to be twice as fast. Your first question that you're going to pause this video for and think on your own is going to be, if our original one cycle, how do you spell cycle, is 360 seconds, for our new twice as fast one cycle is going to take how many seconds? Write that into your notes, pause the video to think about it. And when you're done pausing right here, I know that twice as fast means I'm going to take 360 seconds, and I'm going to divide this by 2 to get a new total of 180 seconds right here. So 180 seconds. Now, let's graph this thing. But before we graph this thing, I want to go back and write in our height function right here. You guys know this as y is equal to our radius, 100 sine of x right here, or t because it's in seconds. T or x is fine. Now back to the twice as fast screamer. I want to graph this thing, and I want to see how it's going to be different from my original screamer right here, okay? So I'm going to put my y-axis like this, I'm going to put my x-axis like this, and 360 was right here, but I know that my new cycle will only take 180 seconds. I'm going to put 180 right here. And I know that half of 180 is going to be 90. I know that half of that 90, in between 0 and 90, is 45. And the number in between 90 and 180, I think that's going to be 90 plus 45, which is 135 seconds. So now we kind of have a compressed sine graph. It's got like, it's been squished horizontally here. So now at 0 degrees, it still starts at that 0 height. So at 0 seconds, it's still at 0 feet. At 45 seconds, though, it's going to be at our tallest point here, which is 100 feet and negative 100 feet. So tallest height right here at 45. At 90, it'll be back down to 0 feet. At 135, it'll be at the negative minimum, negative 100, and then right back up here will be at 180. I'm going to press the focus button just to make sure that you guys can see this. How's it going? Maybe? All right. Okay. So at 180 seconds, we're back up here. We've completed one cycle. So I'm going to go up like this, and down like this, down like this, and up like this. Oops. Like that. And now this thing keeps going here. So if I wanted to, I could graph the next cycle here as well. 180 to 360. Half of that, I think, is going to be 270. Now half of that, I think, could be 45 plus 180, which I think is 225. 225 seconds. And right in between here is 45 plus 270, which is 315. We could draw a whole nother cycle right here. At 225, we'll be back up at the maximum. 270, back down at the midline. 315, back down at the minimum. And 360, back up here. So we can do another cycle of this twice as fast. Right here. Now, your next pausing opportunity here is going to be this. I want you to tell me what is the period in seconds of this new screamer here. What's the period in seconds? Pause right now, think to yourself. And coming back here, we know that the period is the length of one cycle on the x-axis. So from here it starts at 0 and all the way until that pattern starts repeating is right here. So this distance right here is 180 seconds. Now, what you guys did, a lot of you guys did this on Friday, but what we didn't talk about here was what does that do to the height function? So we know from the Desmos activity that the height function is not going to be this. I'm going to write down the wrong one. Y is equal to 200 sine of t, we'll say. No, that's not how we do this. 200 would make it taller, but it wouldn't change the speed. To change the speed, we need to go into the inside of the sine. So y is equal to 100, which is our radius, sine of, and since it's twice as fast right here, I'm going to put 2t. If you were to graph this in Desmos, which I want you to do, I want you to pause the video in 1 second and put this into Desmos right next to our height function from the original, you'll see that compressed feeling here that we were talking about today in class, okay? What I want to do right now is I want to go to another example. So the Screamer engineers are talking about getting really crazy here, okay? They're talking about doing a 5 times as fast. 5 times as fast Screamer. So again, I'm going to give you guys a pausing opportunity here. We know that the original Screamer, one cycle, took 360 seconds. Now, for this new one cycle is going to take how many seconds? Pause, think about that, go back and replay some of the video, whatever you got to do to process here, guys. So pause and think about what will the new cycle, how long will that cycle take here, okay? And you're back here. So the one cycle of the new one, I'm thinking this. If it's 5 times as fast, it should be 1/5 of that length. So to find that out, I'm going to think 360 seconds divided by 5 right here. And, you know, if I don't have this memorized, because why would I have that memorized? I can go right here to my calculator and do 360 divided by 5. That gets me 72 right here. Okay, so I know that my new cycle is going to be 72 seconds long. That is way faster than the original Screamer. Now, let's try to graph this thing here. And if you want to, pause the video in your notes, graph this thing on your own, and then turn the video back on to see if you're doing it correctly here, okay? So I'm going to graph this. I'm going to put my y-axis. I'm going to put an x-axis right here. Now, I know that it's 72, so I know that if 360 was here, 72 is way out here, but I might not have enough room for that. I'm going to just put 72 out around right here. 72 seconds. Now, what is half of 72? I don't know, you say. Well, I'm going to do 72 divided by 2 in my calculator here. I got 36, so I know that halfway is going to be 36 seconds, okay? Now what's half of 36? Well, that one I believe is 18. And what's this number right here? I know that's going to be 18 plus 36, which I think is going to be somewhere around 54 seconds. That will be my 3/4 point here, okay? Now, the screamer still goes up to 100 feet. They haven't changed how big the screamer is, just how fast it is rotating. So at 0 degrees, at 0 seconds, my rider is going to be at 0 feet. At the quarter point, 18, it's going up to 100 feet. At 36 seconds, it's going back down to 0. At 54, we'll be going down to negative 100. And at 72, we'll be going up to our loading point again, completing one cycle. Let's do our curves here. And there we go. And we could make more of these. We definitely could. But this right here is how we could graph this 5 times as fast screamer. Now, pause opportunity, period right here of this new one, please. What is the period of this screamer? Pause and answer. It's going to be our length from 0 to 72. I got 72 seconds right here. Now, how about our height function for this new screamer right here? Well, did the 100 change? Have we changed how high we're going? No. So we know it's going to start the same. 100 sine. But we know it's not just going to be x. We know we're going 5 times as fast right here. So we know that we're going to go 100 sine of 5. And I'm going to put t right here. I changed the variable on you a little bit. 5t or x, depending on what your input variable is. Okay, that's going to be how we go about that. Okay. The last thing I want to do before we leave here, as this video is getting mighty long, is I want you to think about this. Some engineers were like, why are we going so fast? We're going to go, for our new screamer, put a little line right here, we're going to go half as fast. They're like, let's make it slower. Interesting idea. So we have a half as fast screamer. We know that our original screamer, one cycle, was 360 seconds. Pause opportunity. The new screamer, one cycle, will be how long? Do your calculations, think about it, pause your video. Coming on back right here, one cycle for a half as fast. So that just means it's slower. So this means that it's going to be slower by a scale factor of 2, by times 2. So I know this 360 seconds, we have to actually multiply that by 2 to get our new total of 720 seconds right here. 720 seconds. And folks, if you wanted to graph this thing, which hey, I do, you can pause this and do it and then come back and see if you did it right. Y-axis, x-axis right here. 720, holy buckets, that's way out here. That's going to be how long it takes to complete one cycle. Half of that is 360. Half of that, or a quarter of the total, is 180. And I think 360 plus 180 is 540. That will be our 3/4 spot right here. 100 doesn't change, and negative 100 doesn't change. So I know that we're starting up here at a 0 when we load at 0 seconds. We're going up here to 100. We're going down here to 360. At 540, we're going to go down to the minimum. I do this kind of strangely, but that's okay. We're going to go like this, whoop, and we're going to come back up here. Now, our height equation right here, our height function, it's going to be a little bit harder. Our 100 doesn't change, sine doesn't change, but we're not going 2x, because that would be twice as fast. We want to go half as fast. So guys, guess what? Half x. That's going to be our height function. Now, before I end this thing, oh boy, it's got long. I want to tell you what your weekend homework is going to be. And I'm going to show you this right here. Feel free to go back and pause. This is your homework that I'd like to be emailed to me by Sunday. Email to me by Sunday. Just a picture is fine. Email a picture. Okay? Your job is to figure out for the screamer a 3 times as fast screamer. I want you to find out how much one cycle is going to take. I want you to graph it, and then I want you to come up with your height function. After that, I want you to take a picture. Take a picture and email to me through Canvas or through Gmail here, okay? Let me know if you have any questions through email. Thank you very much for watching this very long video. Have a good weekend, guys.